Thanks for click this video. Now I will talk about some applications of deep learning. If anyone interested this type topic, please subscribe our channel. There have a lot of types application in deep learning. But we will describe some application. Automatic speech recognition. Large-scale automatic speech recognition is the first and most convincing successful case of deep learning. LSTM-RNNs can learn very deep learning tasks that involve multi-second intervals containing speech events separated by thousands of discrete time steps, where one time step corresponds to about 10 milliseconds. LSTM with forget gates is competitive with traditional speech recognizers on certain tasks. The initial success in speech recognition was based on small-scale recognition tasks based on TIMIT. The dataset contains 630 speakers from 8 major dialects of American English, where each speaker reads 10 sentences. Its small size lets many configurations be tried. More importantly, the TIMIT task concerns phone sequence recognition, which, unlike word sequence recognition, allows weak phone bigram language models. This lets the strength of the acoustic modeling aspects of speech recognition be more easily analyzed. The error rates listed below, including these early results, and measured as % phone error rates, per, have been summarized since 1991. Image recognition. A common evaluation set for image classification is the MNIST database dataset. MNIST is composed of handwritten digits and includes 60,000 training examples and 10,000 test examples. As with TIMIT, its small size lets users test multiple configurations. A comprehensive list of results on this set is available. Deep learning-based image recognition has become superhuman, producing more accurate results than human contestants. This first occurred in 2011 in recognition of traffic signs and in 2014 with recognition of human faces. Surpassing human-level face recognition, deep learning-trained vehicles now interpret 360 degrees camera views. Another example is facial dysmorphology novel analysis, FDNA, used to analyze cases of human malformation connected to a large database of genetic syndromes. Visual art processing. Closely related to the progress that has been made in image recognition is the increasing application of deep learning techniques to various visual art tasks. DNNs have proven themselves capable, for example, of a. Identifying the style period of a given painting, b. Neural style transfer, capturing the style of a given artwork and applying it in a visually pleasing manner to an arbitrary photograph or video, and c. Generating striking imagery based on random visual input fields. Natural language processing. Neural networks have been used for implementing language models since the early 2000s. LSTM helped to improve machine translation and language modeling. Other key techniques in this field are negative sampling and word embedding. Word embedding, such as WORD2vec, can be thought of as a representational layer in a deep learning architecture that transforms an atomic word into a positional representation of the word relative to other words in the dataset. The position is represented as a point in a vector space. Using word embedding as an RNN input layer allows the network to parse sentences and phrases using an effective compositional vector grammar. A compositional vector grammar can be thought of as probabilistic context-free grammar, PCFG, implemented by an RNN. Recursive autoencoders built atop word embeddings can assess sentence similarity and detect paraphrasing. Deep neural architectures provide the best results for constituency parsing, sentiment analysis, information retrieval, spoken language understanding, machine translation, contextual entity linking, writing style recognition, text classification, and others. Drug discovery and toxicology. A large percentage of candidate drugs fail to win regulatory approval. These failures are caused by insufficient efficacy, on-target effect, undesired interactions, off-target effects, or unanticipated toxic effects. Research has explored use of deep learning to predict the biomolecular targets, off-targets, and toxic effects of environmental chemicals in nutrients, household products, and drugs. Mobile advertising. Finding the appropriate mobile audience for mobile advertising is always challenging, since many data points must be considered and analyzed before a target segment can be created and used in ad serving by any ad server. Deep learning has been used to interpret large, many-dimensioned advertising datasets. Many data points are collected during the request-serve-click internet advertising cycle. This information can form the basis of machine learning to improve ad selection. Image restoration. Deep learning has been successfully applied to inverse problems such as denoising, super resolution, inpainting, and film colorization. These applications include learning methods such as shrinkage fields for effective image restoration,